How are you, my friends? This is review questions number 1 on algebra of matrices, inverses, and determinants. Question number 1, given the matrices M and N, each one is 2 by 2, such that 3i minus M is equal N squared, where I is 2 by 2 identity matrix. Find the value of X times Y. So first we look at this equation, 3 times I minus M, this matrix here, is equal N squared. N squared means N times N. So we have to multiply first N times N. So 2 minus 1, 3, 0, 2 minus 1, 3, 0. We do not square each entry, remember. So we multiply N by N. So remember to multiply row by column. 2 times 2 is 4, minus 1 times 3 minus 3, 4 minus 3 is 1, etc. You can multiply 2 times minus 2, minus 1 times 0, you add, you get minus 2. I is 1001, multiply that by 3, it will be 3003. You subtract here, 2 matrices, 2 by 2, subtract 2 by 2, we get this matrix equation. So we can equate now. X minus y is equal minus 2, 2y minus x is equal to 6. So this is a linear system. We can solve by elimination or substitution or Gauss-Jordan. Then y will be 4. So we can just add directly here. Y equals 4. You can put that in any of the equations. I can use x equals minus 2 plus y. This is the first equation. X will be 2. So x times y will be 2 times 4 is 8. Question number 2, given the matrices x and y, each one also is 2 by 2, find the sum of all entries on row 2 of matrix Z. Z means yx minus xy. So what do we have to do? Multiply y times x, multiply also x times y. In general, these matrices are not the same. Then we subtract. This is Z. So we can find the sum of the entries on the row number 2. So this is an easy question. Remember now, in general, AB not equal to BA. So to find Z, I put YX. Y is the second one here, minus 1, 3, 1, 5. X is 4, 0, minus 3, 2, minus X. This is the first one, and then y is this one, minus 1, 3, 1, 5. Multiply yx, you get minus 13, 6, minus 11, 10. You know, multiply row by column, row 2 by column 1, row 2 by column 2. Minus xy. So you get also this 2 by 2. You subtract 13 minus 4 will be minus 9, 6 minus 12 will be minus 6, etc. This is Z. What do we need? The sum of the entries on row 2. So we just add minus 16 and 9, and the answer is minus 7. Question number 3, given the matrices A, 7 minus 3 minus 2, 1, and BA, this is the product, given minus 16, 7, minus 35, 15. What do we need to find? The matrix B. And also we need the sum of all entries on column 1 of matrix B. So first we have to find B is 2 by 2. So what do we do? This is a little tricky question. We start here with this given. BA is given minus 16, 7 minus 35, 15. Multiply by A inverse on the right side. A inverse here, A inverse there. Remember, when you multiply A times A inverse, that will be I, the identity matrix. B times I is B. So we need B. So now B will be this matrix here, minus 16, 7 minus 35, 15 times A inverse. So I have to take this A and find the inverse by the formula. Remember the formula, 1 over AD minus BC. Switch the main diagonal, multiply with minus on the other diagonal. So A inverse will be 1 over 7 minus 6, 1, 3, 2, 7. Switch here, the main diagonal, and then multiply with the minus here. So you get 1327. This is A inverse. Now remember, this is the product, this is the given, times A inverse. You cannot write A inverse times this product here. So this is minus 16.7 minus 35. 15 times 1327. This is the inverse of A. So the answer minus 2, 1, minus 5, and 0. In column 1, you take minus 2 and minus 5. You add them, you get minus 7. Question number 4, find the value of K. So this is a K here. If the matrix S is a singular matrix. You can figure out the idea here. Singular matrix means the determinant of the S is equal to 0, and it has no inverse. So what do? Find the determinant of the S. You can expand using cofactors and minors. So let's take row 1 here, because we have here a 0. So A11 times C11 plus A12 times C12 plus A13 times C13. So since A11 is 0, I don't have to find the cofactor C11. I can find the cofactor C12 and C13. Easy to find that. Use the formula. So minus 1 to the power I plus J times the minor, capital M12. This minus 1 is the entry there, and this minus 3 is the entry in the first row, second column. Now to find the minor, you have to delete rows and columns until you get K024 and then K12 minus 2. Simplify everything, you get the determinant of S is equal 14K plus 2 when you multiply all these numbers. Since the determinant is equal to 0, so I can put 14K plus 2 is equal to 0, so K will be minus 1/7. Question number 5, given the matrix T, x minus 1, 3, x plus 1 minus 2, where the determinant of the inverse, the square root of 1/81. What do we need to find? Find the product of all entries on the main diagonal of the matrix T inverse. Here, this is T, so we have to find the value of x. Then we will find the inverse. Then we take the entries on the main diagonal, we find the product. So from lecture number 36, we know the determinant of the inverse 1 over the determinant of the matrix itself. Given the determinant of the inverse, square root of 1/81, which is 1/9. So this is 1/9. So the determinant of T is 9. So I can go to the matrix 2 by 2, find the determinant. To find the determinant of 2 by 2 is easy. X minus 1 times minus 2 minus 3 times x plus 1. This is equal to 9. We get 9 from the given. From this simple linear equation, we get x equals minus 2. Now, the matrix T becomes, if you put here minus 2, it will be minus 3, 3, minus 1, minus 2. Let's find the inverse of T. To find the inverse, we can use the formula here, 2 by 2 inverse formula. So it will be 1/9, because this is the determinant of the T, 1/9. We switch the main diagonal here, minus 2, minus 3, and then multiply with the minus the other diagonal. This is a scalar, 1/9. I can include that inside. So T inverse will be minus 2/9, minus 1/3, 1/9, minus 1/3. Find the product of the entries on the main diagonal. Minus 2/9, you multiply that by minus 1/3, and the answer is 2/27. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.